Hello students, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Anandi, Pune. Today's discussion topic is Recurrent Neural Network. Before moving towards the recurrent neural network architecture, let us first understand the sequence data. What is the sequence data? The sequence data, the example in diagram, you can see the ball is moving in one direction from left to right. Now the movement of the ball at every stage is different. At particular time step, at time second, 1 millisecond, 2 second, millisecond, the movement of the ball is at different places. Now here this is the best example of the sequence data. To predict the direction of the ball from single still snapshot, you had only able to make the random guess because you lack of necessary data. And here you can predict the next, that is the direction of that particular ball at the at right side, left side, or upside or downside. Now, however, in recording the multiple snapshots in succession, you can observe the sequence of the ball position over time. As time moving from one time step to another next time step, then we need to observe the movement of the ball. This sequence provides the enough information to accurately determine the ball's direction, such as the confirming that is the moving to the right. This is another example of the sequence data. Now audio spectrogram chopped into the chunks, and the sequence data comes in many forms. Audio is a natural sequences, and you can chop up the audio spectrogram into chunks and feed that into RNN model. Now, whenever we are working with the sequential data, now also we need to understand what is the sequential memory. The sequential memory refers to brain's ability to recognize and recall pattern in specific order, because whatever the movement of the ball or the audio spectrum, now these all signals are arranged occurred and observed in a sequence only. So sequential memory is required. Now that is the movement of the ball or movement of that particular any object at particular time, and what is the position of that particular object at time. Suppose that let us consider if you are observing the movement of any ball from 15 second, then at 1 millisecond, then 1 second, what is the position of the ball, at 2 millisecond, what is the position of ball, and to store the position of this ball, we require the sequential memory. Now let us discuss one example, that saying the alphabet in our head, that English alphabet from A to Z, saying in your head, easier due to the learning as a sequence, that is A, B, C, D up to Z. But backward pronunciation is harder without the practice due to unfamiliar sequence. Now, a sequential memory aids in recognizing and recalling the patterns a specific order. Now, what is the sequential learning? Till now, we have discussed what is sequential data, what is the sequential memory. By using these two concepts, here we need to understand what is the sequential learning, the process where the model learn data from presented in specific over the time, and it is a crucial task like time series forecasting, speech recognition, and natural language processing. Now in sequential learning, it is in deep learning there are different number of sequential learning models like RNN, recurrent neural network, long short-term memory, GRU. These are the different algorithms we are using for the sequential learning model. Now here I know a few more examples of the sequential data. Now here you can see this is the temperature data with respect to the time. You can check the temperature, and this is stored in a sequential format. Ring width, that is a meteorological data. Now here the frequency of the spectrogram. Now these are the different example of the sequential data. Now there are different types of sequence prediction models are there. Now here for giving the one input for one in sequence, it generate the one sequence. For giving one input sequence, it will generate the many sequences. Here for many to one sequence, many to many, many to many. These are the different sequence prediction models. Now one-to-one and many-to-one neural network, that classic feed-forward neural network architecture with one input and output. And we can use these type of models for the different purpose. Now we can also use the one-to-many image for image captioning, one fixed size image as an input, and varying the length of words as a or phrases, means one input is giving and we are generating the multiple captions for the given image. Many to one categorizes emotion using succession of the words and paragraphs as an input. There are a lot of examples of sequential data where we can apply the deep sequential learning algorithm. Now there are different types of sequence prediction problem. Let us discuss these the four main types. First one is the sequence prediction, second one sequence classification, third one sequence generation, and fourth one is the sequence to sequence prediction. Now let us discuss the sequence prediction. Now in sequence prediction, the sequence is given. Now here we need to predict the next number. Now this 1, 2, 3, 4, 5 sequence prediction model. Now here next number is 6. Okay, now here we are predicting the sequence based on the provided sequence. Next, sequence classification. Now based on the sequence is given, based on this we are assigning some tags to the sequence. This is an example of sequence classification. Also you can go through the different example like anomaly detection, sentiment analysis, and DNA sequence classification. Next, sequence generation. Now in sequence generation, again you can generate the sequence, you can give the images as the input and generate the sequence. Now one input is image is given and caption is generating in different sequences. Man riding a bike. Now here the sequence is generated, and this is the example for sequence generation. Another few more examples are there like text generation, music generation, and image captioning. Next, sequence to sequence prediction. Now in sequence to prediction, one sequence of 5 digits are given and it generating predicting the sequence of 6 digits or characters in n number of sequences. The example: multi-step time series forecasting, text summarization, and language translation. These are the examples of sequence to sequence prediction. You can here you can see a few more examples of the where we can use the sequential learning models. Now automatic image generation. Now here you can see these are the images. Now you can generate the n number of caption for the given image. Here automatic translation of the text. Now translation. Now you are giving the input in one language and translating into another language. Next, automatic handwriting generation. Now you are giving input in a input image as an input, handwritten text input image as an input, and then it will be generate the editable text. Okay, now next point, let us discuss recurrent neural network. Now recurrent neural network, this is the widely used neural network for the sequential learning, and which will handle the sequential data and preserve the sequential memory. Now here in this example, now here this RNN replicates sequential memory in traditional neural networks such as the feed-forward neural network. Okay, now here you can see, now here input is given. Now this is your feed-forward neural network. Input is given and it will perform the processes and it will generate the output. In recurrent neural network, given the input, and here its hidden state input, again it will be given as an input for the next step. This is the difference between feed-forward neural network and recurrent neural network. Now this recurrent neural network is also called as looping mechanism that act as a highway to allow information to flow from one step to another step as the input is accepted by in recurrent neural network in sequential format. So input RNN execute, one RNN model is executing for each and every sequence in a sequence which is appeared on every time step, and the passing hidden state to the next step means the hidden state of one input will be the pass to the next time step as a input. Now let us discuss one example for the recurrent neural network. Now this is the example of for next word prediction. Now for this we need to pass the word through the RNN model. Now there is one text that breaking the sentence into word. What time is it? This is the complete question. Now we are passing this as a sequence to the RNN model to predict next word. Okay, or train the model, train the sentence for the predicting next word. Now what time is it? 9 question mark means there are 5 words are there. We are first breaking into the words. The first word feed data what into RNN, and RNN encodes what and produce the output. Next step, then time keyword will be passed through the RNN and hidden state from the previous step, and RNN has the information both word, what and time. Now let us discuss in a diagram. Now here 5 RNN will execute, 1 RNN for each word will execute. Now initially for first sequential data, first word will be given as input what. Now what, for this what it will generate the output what. Also it will generate some hidden state value, and this hidden state value it will be the input to the next step along with the its current input. Now at time step 2, now this is at time step 1, at time step 2, at time step 2, the input is given, the current input is given as a time keyword as well as the hidden state of the what. Means this this hidden state of the at time step 2, it will hold the information of two keywords, two words, what and time, and then it will display the output. Next, again next words are given, but as again next key sequence is given is 8 and question mark. But here again the sequential memory is preserved less for the words which are appeared at 0 index, okay, at first index. So if you observe here, the maximum memory preserved for the sequential memory is for the question mark, so you can remember the question mark, and less memory for it, and very less memory for is, time and what, and very negligible memory is stored for the keyword what. Okay, now here you can see the pseudocode for the RNN control flow. Here RNN feed, this is the feed forward neural network. Hidden state, there are these are the hidden state. Now output and hidden state is generated by each RNN. For each word we are executing RNN along with the hidden state, and it will generate the output as well as the hidden state. Okay. Why not feed forward neural network? We are not possible to use for the image data set, as this image data set we are using to generate the output, but it is not possible to generate the output at each time step, so we are not using the feed forward neural network for the image data set. Now here now let us consider this is the example of recurrent neural network. Now here for every time step, suppose there are number of inputs are there, input 1, input 2 and input 3. These are the three inputs are given. The input 1 at time step t minus 1, now time step t2 at we are passing second input and third input. Now here we are generating, performing the operation, weighted summation of weighted sum we are performing, we'll get the hidden state, and then hidden state of this current input it will be passed through the next step. Okay, and same way here at every time step we are passing the hidden state output of the previous state to the next state to capture the sequential memory of all words or inputs in a given sequence. So here diagram it is shown in a recurrent, so it is called as recurrent neural network. Okay. Now what are the recurrent neural network? Recurrent neural network are a type of artificial neural network designed to recognize pattern and sequences of the data such as text, genomes, handwriting, spoken words, numerical time series data emanating from the sensors, stock markets and government agencies. For better clarity, consider the here there are different example we can consider for the recurrent neural network. Now this is the architecture. Here we can see in recurrent neural network, this is the input is given along with some weight, perform the weighted multiplication x0 multiplied by w0, and it will generate the h0. Okay, and for h0 then it will, this h0 value will be passed through the next activation function to generate the output. Now here h0 is also will be the input to the next time step, means the input is given in sequential manner, the input at the time step 1, time step 2, time step 3, and then we are passing through the input to the every hidden layer. Okay, now here how we are calculating the hidden layer. Now hidden layer value we are calculating, that is the multiplication of weighted hidden state and wi multiplied by xt and wrht, and then plus bias, and then we are calculating the ht for the next state. Okay, Now in RNN, whenever we are RNN, we are using the RNN for the sequential data, then there are some challenges in RNN, and so that its performance will be low due to the vanishing gradient. Let us discuss the what is the vanishing gradient. You may notice that here odd distribution of the colors in a hidden in what is time in example. Now here the very less contribution, less weightage is given for the memory reserve for the previous words. So this is due to the vanishing gradient problem. Now, what is the vanishing gradient problem? When training deep neural network, including the RNN backpropagation algorithm is used to update the weight of the network. This involves the calculating the gradients of the loss function and with respect to the weight, and which are then used to adjust the weight in a direction that minimizes the loss. Okay, now whenever we are trying to reduce the loss, because obviously for every neural network we are trying to reduce the loss using different optimizers. Now here, whenever in RNN we are trying to reduce this draw, calculating gradients of the loss with respect to the weight, which are then adjust the weights in direction that minimizes the loss. And here the RNN susceptible to in this problem due to the recurrent structure, because recurrently we are updating the weight and at every time step. So if in what happened at some cases the value of weight will get nearer to 0 or less than 0. So in this case value of weight is 0, means learning rate will be 0, and into that function compress value to the small range and gradient shrink nearer to 0, making it difficult to learn the dependency far back into the sequence. And once the value of W will get 0, means the training will be stopped and there will be less training. Now here you can see in every backpropagation in sequence model, there is a chances of that value of gradient will get zeros, and that will be, and the value of that gradient will be vanish. This is the problem. This problem is called as vanishing gradient problem. Okay, due to this, because of the vanishing gradient problem, RNN does not learn the long-term dependency across the time step. So it is not possible to preserve the memory for the previous words in a given sentence for predicting the next word. That means there is a possibility that word, the word and time are not considered when trying to predict the user's intention. The network then has to make the best case is it. Okay, but the network will not give the best result for the what time. The pretty ambiguous and difficult even for the human. So not being able to learn the earlier time step, because the network has the problem is called as short-term memory problem. Okay, here you can see this is the vanishing gradient problem. The value of W will get nearer to 0, less than 0 or 1, then at that time the vanishing gradient problem occurred. Now here with error calculated, the changes in error with respect to change in weight is calculated, but with which learning rate this has multiplied with the same time. So the product of the learning rate change lead to the value which is actual change in weight. So the change in weight added to the old set of weight, and every training iteration has shown in figure. Now here this value of the weight will be reduced, and this issue when the weight is multiplied and value is very less. So considering the predicting, now let us consider one example. A sentence, I am going to France, and you want to predict I am going to France and the language spoken there is. Now in this case lot of iteration will cause the new weights extremely negligible, and this leads the weight are not being updated. Now this is the major challenge occurred in a recurrent neural network. The RNN struggle with the short-term memory, especially in processing the long sequence. The vanishing gradient problem causes the gradients used to update the network weights to become smaller. This lead to minimal updates to early layers and causing them to stop the early learning effectively. And this result in forgetting important information from earlier in a sequence, contributing to short-term memory issue. We can solve this short-term memory problem using long-term dependencies, and there are various solutions so that we can extend the working of the RNN using different types of deep sequential learning models. Long-term dependency occurs when the model need to use information from the distant point as a sequence to make a prediction or decision at later stage. This is the important past data span many times per step, and it's critical for the tasks such as the language modeling, sequence prediction, and text summarization. Key points. And for the long-term dependency, the temporal gap is more relevant information may be far back in the sequence, not immediately adjacent. Memory requirement, more memory is required to preserve the long-term dependency. Model must remember and integrate the distinct past data and challenging further standard models. Challenges: the RNN struggle with the vanishing gradient problem, making it difficult to retain the information over the long sequence. So, there are two solutions to extend the working of the RNN model to resolve the vanishing gradient problem, making it difficult to retain the over the long sequence. And here, there are two algorithms are introduced, that are long short memory network, that is a LSTM, which use the gates and memory cells to manage and retain the long-term information. One more network is there, that is called the gated recurrent unit, that simplify the LSTM architecture while still capturing the long-term dependency. This is all about how we about the sequential learning, sequential data, sequential memory, and how to use the RNN recurrent neural network to handle the sequential data. Also, we have discussed the challenges in RNN due to the vanishing gradient problem, and so that we are not able to preserve the long-term dependency in sequence. So there are two solutions, LSTM and a GRU model we can use for preserving the long-term